let us write one property of measures of dispersion. If x and y are two variables related as y equal to a plus bx. Whenever you write like this, you say there is a linear relationship between x and y. Linear. Why linear relationship? Because if I plot this on a graph, the knowing the values of a and b, these two are some numbers, a and b, and then if I substitute value of x, we will get a value of y. Likewise, if I substitute different values of x, I'll get some different values of y. Then those x comma y, whatever values you are having, if you try to plot it on a graph sheet, you will get a straight line. That is why you call it as a linear equation or linear relationship between x and y. Whenever I write y equal to a plus bx, I call it as a linear relationship. Then a range of y can be calculated as modulus of b times range of x. Then mean deviation of y can also be calculated as modulus of b times mean deviation of x. Similarly, standard deviation of y can be calculated as modulus of b times standard deviation of x. Similarly, the last one, quartile deviation of y can be calculated as modulus of b times quartile deviation of x. So this particular property, it is applicable for all the absolute measures of dispersion, right? That is why range, mean deviation, standard deviation, quartile deviation, everything came. So let's consider this particular data given in the question. I already wrote the class boundaries and the cumulative frequencies. We'll try to understand each of the measures of dispersion. How do we calculate for this frequency distribution? It is actually a grouped frequency distribution, but the profits are not continuous because it is ending with 19, starting with 20, ending with 29, starting with 30. For that reason, I made class boundaries, which we already seen earlier. How do we create a class boundaries? I think the same data was used earlier to calculate some median and all those things, median or mode, right? Now, with this data, first let us find out how do we calculate, let's say, range. How do we calculate range? Range is nothing but highest minus lowest, right? Assuming that the profit cannot be less than 0. Uh, Profit cannot be, here it is written as less than 10. We will assume that the profit cannot be less than 0. So that means the least profit can be 0, we are going to assume. So for that calculating range, I am not going to use the class boundaries. I'll be using directly the one what is given in the table beginning. So less than 10, I'm going to assume it as 0. That means the least value is assumed as 0. Highest value is given here as 59. So the highest is 59. So the range is 59. Straight away we calculate like that. Then the next is coefficient of range. We know it is h minus L divided by h plus L, which is, we already calculated h minus L, it is 59. H plus L is also 59 plus 0. So ultimately it is 1 only. So coefficient range is 1. Now, the first two, this is absolute measure range, this is relative measure. Now, let us calculate one by one mean deviation about, let me first calculate median. Instead of writing capital A, I am using capital A as median, which will be what? It will be summation. This is a frequency distribution. That means we should have f times modulus of x minus median divided by capital N. That means primarily we need to find out the median. Let's say, what is median? We know median is L1 plus L2 minus L1 into M minus C divided by F suffix ME. Primarily, we need to find out what is our M value. M is capital N by 2 for a median. N, we already know it is 92 by 2, so it becomes 46. Now, how do we identify the median class? We need to look into where this M occurs to understand what is our median class. So up to 5, it won't come. Up to 23, it won't come. Up to 61, yes, it will come. So our median class is 19.5 to 29.5. Now this will be 19.5 plus, open a bracket, 29.5 minus 19.5 multiplied by 46 minus, what is C? C is the cumulative cumulative frequency of the class preceding the median class. We know median class is this. Preceding that will be this. The cumulative frequency is 23. So let me write here. Divided by frequency of the median class. This is the frequency of median class. Let me write 38. So our median will be what? 19.5 plus, this is 10. So 10 multiplied by, this is 23 divided by 38. So how much it is? Uh, 230 divided by 38. So it is 6.05 plus 19.5. We get 25.55 something. I'll make it 25.6. Now, once we found this median, what I'm going to do, I'm going to copy this table, because for calculating mean deviation about median, I may need a table fresh. I'm going to copy the same table. Then here, I need to calculate this modulus of x minus median, one column. Then the next column is f multiplied by modulus of x minus median, another column. So I'm going to insert two columns. Like this, let me write here modulus of x minus median. Median is 25.6. So I'll write 25.6. Then, and let me copy this. And here I will write that F. So first one, X, I need X also, sorry. That means, let me introduce one more column. Here I may write our X. X is the, I can consider the middle value. So here I think 9.5 to 19.5, I will consider the middle value. 9.5 plus 19.5 divided by 2, it is 14.5. 14.5. The next one will be 24.5. Here it is 9.5 by 2. I'll consider it as 4.7, sorry, 4.75. Because here the gap is 10, here the gap is 9.5. That is why here we are not writing it as 4.5, we are writing it as 4.75 because of the gap. Here this gap and this gap are different. For that reason, here the middle value is not exactly 4.5, it is working out to 4.75. Then the next one is 34.5. Then 44.5, then 54. So we got the mid values. We can even write it as 4.5, no harm in it, but let us consider the same thing only. We keep it as right. So now here, x minus 25.6 means 4.75 minus 25.6. You get 20.85. 20.85, and since there is a modulus, even though it is negative, I am writing it as positive. Next one, 14.5 minus 25.6. I get 11.1 negative, but I am not writing negative because it is having a modulus in it. The next one, 24.5 minus 25.6. You get 1.1. Next one, 34.5 minus 25.6, you get 8.9. Then next one will become 18.9. Next one will become 28.9. Let me check 54.5 minus 25.6. Yes, 28.9. The next step is frequency multiplied by this value. Frequency is available here. So 5 into 20.85, we get 104.25. Then 18 into 11.1, 199.8. Then next one is 38 multiplied by 1.1. You get 41.8. Then the next one, 8.9 into 20, you get 178. Then 18.9 into 9, we get 170.1. Then we have 2 multiplied by 28.9, we get 57.8. Let us sum it up. Plus 170.1 plus 178 plus 41.8 plus 199.8 plus 104.25. We get 751.75. So since we now got f times x modulus of x minus 25.6 as this, we can now find out this mean deviation about median. So I can say now mean deviation about median is equal to this value whatever we obtained divided by total frequency, which is 92. So that will give us 8.17. That is our mean deviation about median. Now let us calculate coefficient of mean deviation about median is equal to mean deviation about median divided by median. And mean deviation about median, we just calculated, it is 8.17 divided by median. Where is median? We calculated 25.6. 25.6. So that will give us 8.17 divided by 25.6. We get 0.32, because it is, you are getting 3.3191 something. I'm rounding it off to 0.32. So in case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.